Welcome to Chapter 14. We spent Chapter 13 learning about exponential growth and decay. Why? Why did we learn it? In Chapter 14, it's a quick chapter. It's 2 sections, but we want to be able to take real-world data, and if we can fit an exponential model to it, we can use it to predict. So we're going to talk about taking data, fitting a model. Remember, we did this in the past with regression, so we'll review that. But first, we have to recognize what exponential data might look like. How to recognize it. Let's take an exponential equation that looks something like this. 2 to the x. All right, and if I made myself a table, okay, I'm going to plug in. For x, I'll put 0, 1, 2, 3, and so on. And for f of x, we'll plug in what we get. 0, 2 to the 0 is 1. This would be 2, 4, 8, 16, 32, 64, 128. Now, we wrote the data knowing that the model looks like this. But what if you were given this data? How might you recognize that it's exponential? Meaning, we have this base here. Well, we do it by looking at this value divided by the value in front of it. So it's always something, you don't have to worry necessarily about how I'm writing this, but it's going to be 2 divided by 1. All right, that's 2. Now we're going to look at the next one. What's this value divided by the 1 in front of it? Well, that happens to be 2. What's this value, this f of x, divided by the 1 in front of it? Notice that each time we do this, it equals 2. That means this is multiplied by 2 each time, right? F of 0 is 1. To get to the next value, right, we would multiply by 2, because this is 2 times 2 times 2, all the way up to whatever, how many times x is. So the fact that these are consistently the same number tells us that this is exponential data, okay, with the multiplier or base of 2. So in the book, they give us some examples. We're going to see if we can recognize that this is exponential data. So f of 1 is 4 over 1 equals 4. Okay. F of 2 is 16 over f of 1. Okay, that equals 4. If we do this all the way out for this particular set of data, we get 4. They're consistently 4. So that means the base for this exponential, now that we know its exponential function is 4, this would look like 4 to the x. Now over here we have, all right, 7 over 1 is 7. All right, 13 over 7 is closer to, if I did it on my calculator, 13 divided by 7. Okay, that's 1.86. The next one would be 19 over 13, 1.46. These are not consistent, even by rough estimation. So this is not exponential. This one is yes. Let's look at this one. So here we have 4 over 1. Here we have 13 over 4, which is 3.25. 4 over 1 is 4. Then we have 28 over 13. Right, if I put that in my calculator, I get a fraction 20 over 13, just for rough numbers. That's 2.15, not exponential. So we want to be able to recognize the data. Now, if you look at a scatter plot, it's going to look something like what we've been looking at in Chapter 13. Okay, we have to remind ourselves how to use the calculator to look at the data and do a regression. But so I have this in the